Hello everyone. So today we're going to explain what is normal distribution in Six Sigma. Okay. So let's find out first the agenda today. So what are we going to cover today in today's video? So first of all, we need to understand what is normal distribution, then the core characteristics of normal distribution, how to know data is normal, when we should use normal distribution, 68, 95, 99 rule in normal distribution, why it is called a bell curve, why Six Sigma uses normal distribution, real world applications, key takeaways. All these things are going to explain in today's video. So we are going to cover everything about normal distribution. After this video, you'll become the master to understand the fundamentals of normal distribution. So first of all, we need to know that what is normal distribution? What is the definition of normal distribution? So normal distribution, it is a statistical pattern where data points cluster around the average and fewer data points are at the extremes, and it creates a systematic bell-shaped curve. Okay, most observations around the center and fewer observations are at the extremes. Okay, so now we need to know that why it is called a bell curve, because the graph that is being formed, it is a bell shaped. That's why it is called a bell shaped curve, because maximum data points around the center and fewer data points occur at the extremes, and it creates a bell shape. That's why it is called a bell shaped curve, or normal distribution also called a bell curve. Now we need to know that what are the core characteristics of the normal distribution. First of all, first one is symmetrical distribution. You will see that 50% of the data points around at the left hand side of the mean, and 50% of the data points at the right hand side of the mean. Okay, so it creates a systematical distribution. Second point is mean is equal to median equal to mode. Third point is it creates a bell shape. That's what is called a bell shaped curve. And the fourth point is that the tail never touches the x-axis. It will never meet the x-axis. Okay, so these are the characteristics of the normal distribution. So hello, this is Surajit Banerjee, a Lean Six Sigma Master Black Belt. I welcome you all to our channel, the Lean Six Sigma World, your go-to place for mastering the concept of Lean Six Sigma in all aspects. I have launched this book. This is called Untold Story of Lean Six Sigma. This book will be a one-step solution for you to learn and master the fundamentals of Lean Six Sigma in one single go, because I have given all the practical examples and guidelines for you to learn and master the fundamentals of Lean Six Sigma. This book will be a comprehensive guidelines for you to understand the fundamentals of Lean Six Sigma. This book is the Amazon #1 bestseller, and I have achieved the Amazon #1 best-selling author from the Amazon. Okay, this book is available everywhere, Amazon, Flipkart. So you can go and check this book. I have given the links of this book in the description section. So you can go and check this book. Okay. Now I am moving into another concept, that is basically when we should use normal distribution. When the data is continuous, we should go for normal distribution. When the data is approximately symmetrical, we should go for the normal distribution. And when the sample size is sufficiently large so that you can create a curve of well shape, for that sample size should be higher, large. These are the conditions for which we should use normal distribution. Now we need to understand that how do you know that the data is normal. Now when you plot the data sets, then there are some visual methods are there by which you can understand the data is normal, like histogram, bell curve, or box plot. Okay, but there are also some statistical tests are also available by which you can find out whether the data is normal or not, like normal probability plot, Anderson-Darling test. Anderson-Darling test is very, very popular to find out the normality of the data. Okay, so these are some tests available by which you can understand whether the data is normal or not. Now we need to understand that why Six Sigma uses normal distribution. Six Sigma uses normal distribution to measure the variation. Okay, you can find out what is the spread, what is the spread of the data set. So you can measure the variation. It predicts the performance and it improves the process capability. You can find out the process capability by using the normal distributions. Okay, so that's why Six Sigma projects, we basically go for normal distribution, and we can find out the process performance by using the normal distribution. Now we need to understand that the fundamentals of mean and standard deviation. See, mean represents the center point where the process performance is concentrated. Okay, mean is the average of the data set where the maximum data points are concentrated and fewer data points are at the extremes. Okay, and sigma, it is basically standard deviation, which is represented as sigma. Higher the sigma means more inconsistent the process is unstable, variation is more, and smaller sigma represents that the variation is less stable, almost stable process. You can say the variation is less. Okay, so that is being understood by the standard deviation. Now we need to know that what is the rule 68, 95, and 99 rule. What is the meaning of this? It means that 68% of the data falls within the plus minus 1 sigma level. Okay, if you plot the normal distribution curve, you will find that 68% data falls within the plus minus 1 sigma level, 95.45% data falls within the plus minus 2 sigma level, and 99.73% data falls within the plus minus 3 sigma level from the mean. Okay, so this is the fundamentals of 68, 95, and 99 rule. Now we need to understand that what happens if the data is not normal. If the data is not normal, non-normal data may indicate instability, special causes, process shifts, or hidden variation. Now we need to understand some real world applications. These are some real world applications like human height. Okay, you can use normal distribution. IQ scores, you can go for normal distribution. Blood pressure variations, you can go for normal distribution. Examination scores or measurement errors, process variation, you can go for normal distribution. This is the real world phenomena which follows the normal distribution. So what is the key takeaway? The key takeaway is that normal distribution helps organizations to take decision in a correct way, in correct manner. It reduces the defects and it achieves operational excellence. So if you found this video helpful, make sure to like the video, share this video, and comments below your thoughts on normal distribution. Whatever you've learned today, I know you have learned something new from this video. So share your experience in the comments. I'll be happy and obliged to see your comments. And subscribe to our channel and turn notifications for more insightful content. You can also join our exclusive WhatsApp community to get free updates, all listening our tools and techniques, everything for free. So I just want to take this opportunity to thank you all from the bottom of your heart for being part of this journey with the Lean System world. Thank you. Thank you so much.